Well, welcome to all. When I was contacted by NXP to make to keep in charge of this job, they told me about a challenge. After the first week, I discovered that they was not joking. So this is a sort of Qt adventure where Qt demonstrated, in my opinion, to be one of the most flexible platform adaptable to not only to conventional situations, but also to very, very unpredictable and difficult application environment. And this is the reason that I proposed to show this use case. Just a word, what is? SmartStudio is a big platform running on desktop that starts from, to your left, the component that NXP developed for mobile audio, so the small amplifier and DSP signal processor that are in most of smartphones, and then through a hardware interface layer based on DLLs instead of shared library in Linux and so on, work sending data to this application. SmartStudio so is a totally monitoring and configuration system for the specific chip of NXP that are used by few but big customers like Samsung or Huawei, LG, to calibrate and to analyze the response of these components inside of the smartphones. And so NXP developed a series of small boards based on embedded components, for example, maybe Raspberry Pi instead of BeagleBone Black or so similar, to simulate the Android contents in the smartphones and send this data stream. This is just to focus the scenario. The problem of this application, what was that due a series of developments of wrong solution, wrong choices, and so on, it works started with a delay, a tick every sample of about 250 milliseconds. This means absolutely unreliable timeline to acquire and check real-time data from audio sources. So the challenge was just to find a way to optimize and change the timeline of the behavior of this application that works in IDE way, no? A project configuration that depends on the hardware, and for every kind of component, the project is then used by the application to create the user interface environment showing real-time data, controls, every kind of controls that are available on the chip. Well, the solution was not found, okay, this is the problem, I propose the solution. No, it was not a linear path, because it was very difficult to understand software, very mixed with classes that don't, without linearity, developed in Python, so an interpreted language as the base for the digital real-time signal processing. And then the other problem was that there was no documentation, totally undocumented software, thousands and thousands of lines of software without documentation. Okay. The initial idea was that this software was working in PyQt4, based on Python 2.7, and the first idea was to understand how the software was working. So this task was done around the porting of the platform to Qt5. The reasons are almost obvious. First of all, because it is long-term support, because Qt4 is no more supported and distributed and documented, is in queue to be abandoned. And then also because it integrates better with, anyway, with Python. The most important problem I met was that this application was not ready to send on the market or anyway this big customer. Was already in use. So it was impossible to stop, make some changes, make some total revision, and then go ahead and release a new version. The problem was to follow a path, to identify a strategy, to make changes progressively inside the application that is already in use. Working on the porting, the activities, the main important activities was to focus how the application works, what are the issues that make this application so slow, and identify the application logic. So, first curious thing, I worked almost 2 months porting from Qt4 to Qt5, PyQt4 to PyQt5.5.1 under the environment of Python 2.7 with a strong operation of reverse engineering, okay? Just discovering what the application was really. So there was 2 phases. A pre-porting, that is what should be changed, at least to put the system in condition to be upgraded, and a post-porting where the real intervention, real changes in the architecture can be applied. It's important to note that, just to give you a scenario, a starting scenario, that one of the various issues was just a wrong use of strings, no strings definition, so a ton of repeating strings, same messages, same information. There was no correct management of the string themselves. Qt is Unicode, Python is a string, and there was continuously an exchange between Unicode and string, creating a tremendous delay. So, the first apparently simple, easy operation, also for me, I find a wall and to crash again, because it was very difficult without information. When the porting was complete, just only removing all the parts of redundant parts, repeated functions, and so on, we gained at least 25% of performances in the software. Then, at this point, we started preparing the user interface for the first drastic changes. It's all white, but as you can see in the center, the design is like an IDE, like Eclipse, like PyCharm, and is the application that exposes, depending on the hardware and on the project characteristics, the various widgets, various components. Why to show this? Because just to understand, every part you see, knowing Qt is easy, no? Also from Python, I create PyQt components that works by themselves and then are used inside a container. Nothing at all. The issue in the architectural design of the previous application was to use Qt, PyQt5 and Qt like just a bunch of libraries. So every user interface advantages that are the direct callback, the signal for the user interface and the user interaction, just moving a mouse over a widget was all managed under Python inside a mixed architecture that was using also the model part that control the hardware, ask for hardware streaming, and so on. So the first idea was, okay, start with Qt user interface redesign step by step, part by part, using the fastest way and with the better guaranteed results, using a model view controller explained in the exception of Qt, that is not exactly the super standard model view controller, but is more interactive between QML, Qt, and C++, creating all the parts that now was heavy and very time-consuming in the Python environment, exporting, removing them, and replacing with C++ plugins controlled by QML. The problem is that this was not possible at all. Why? Because the application starts with Python, run Python, then Python start the creation of the user interface divided in every widget, in everything, continuously managing the widgets, continuously managing every element of the user interaction. So there is not a top level that can be extracted to control the plugin and to manage a C++ plugin that in theory is faster. We was obliged to start from Python, receive the messages, the information, or the request from the Qt QML user interface, and then from Python create a wrapper for the C++ plugin. So the time that it was possible to gain with the C compiled components was totally lost, and by the Python creating this vicious circle, no? So non-linearity, the problem that the guy is controlled by Python and there is the entire feedback of the user interface by Python makes this impossible. Also another long time spent over testing to be sure, to be trying everything possible to avoid this problem. Anyway, we discovered that it was not possible. So, remained the target that is to create an asset for the application where the user interface is robust but is fast and can't work at the unacceptable value of 20 milliseconds or 150 milliseconds every tick from an audio DSP. Also because there is a very long delay. There are data that you can collect where you're hearing the behavior of the board are absolutely unreliable. It's very difficult also in practice for the users to make tests. So at this point, keeping in mind that the customers want anyway to improve, the first must is to improve performances, then me and also the team that I have cooperated with, working strongly on the Python side, we need to optimize the code to have an idea of what we can do, make faster the entire application. So in some way we had the need to become with an application in some way modular. So the must is find a way to redesign the user interface components in Qt. Just note that I moved the porting from Qt4 to Qt5.5 instead of Qt5.6 that is already that was already available and is again more reliable, faster than the Qt5. It was also due another big limit. All the graphic elements, all the plotting areas of this application that we'll see later was not done in Python, was not done in Qt, but was done with WebView that using HTML, JavaScript, and CSS was receiving feedback from the Python side and was drawing the real-time data. So So it was in the mix, there was also a problem of 3 big blocks that was websites. Consider that this application will show 5, 6 graphs, 10 different graphs that should plot real time. Every graph was a web view instance shown in a widget, all controlled by Python. A track going very, very, very slow. At this point, the first thing after we had a version working on QtCon at last working just as it was before, I've developed a lateral package, another long time in this challenge consumed, that is profiler. The goal was to monitor possibly without as less interference as possible, the Python side of this application, because the Python side was working by itself. The goal was to extract parts and create an independent element, an independent object, just to manage the graphic user interface and the view controller environment for specific parts at a different timing. So, while in the logic, the user interface that is under the direct control of the user has its own timing and make requests to the model that may be okay. In Python, that is slower, is not the best solution, but may be used. Python itself was working with its own timing, polling continuously in a single thread with the hardware layer. So, the problem was to create interface, managing the entire user experience, working at the fastest way possible, the fastest speed possible, and working with its own frequency time independent tasks, and then keeping for now, for the first phase of this project, the Python side working at its own speed as faster as possible. So totally asynchronous, two totally asynchronous systems that are managed only throughout the data flow. So to know where we was going, the idea was to create integrating memory profile, the standard profile class of Python and other features in a system that is a package that can be added everywhere. The package is called, but with a stupid trick, if the package is disabled, there is anyway remains the call to the functions, but there is no time consuming. This is because always the difficult to make interventions, direct interventions on the source of the Python sources. This as an architecture, very easy to implement with a very simplified application than the common Python profiler class. And it is one of the parts that will be available to those interested in on GitHub. Then, at this point, the original idea was the plugin approach, not applicable because this C++ classes was creating a trouble in the mechanism of call because it was not possible to call them directly, driven by the QtQML design. And design is very complex in terms of features, so it was needed to make this. This is not applicable for now. This means that until we reach the goal to remove all the parts that are user interface mixed with the entire Python model, if we can say, this will be the final real beta solution and a further optimization step. In this phase, I have already tried to develop a plotting engine in C++, but tested and worked, but as a matter of fact, using this as an intervention in the application, it was impossible. At this point, the current solution adopted that will survive for a while until the entire challenge, this entire project cycle will be completed, is to adopt the declarative approach. The compromise was to create a very fast, as much optimized as possible JavaScript components that gives anyway a good frequency response in the user interface, making it independent and totally under the control of the QML design and JavaScript. So there is a sort of missing part. That is what I was initially pointing the attention to, that is this graph design parts done in C++. Obviously, to make them working in JavaScript is more difficult because it's a long job work of optimization to reach anyway the target that is required by the user. So this is the compromise that it is now working, and after porting, after documenting the application, after managing the entire system for a long time, it was possible to focus the SmartStudio parts that are not absolutely clear, also now are not yet clear separately, in a separate way, but are focused in a right way to keep them under control. The user live interface is the design of parameters like big pages of switches, parameters, controls, so all the settings that can be done on the chip. And these are normal common widgets, so can be developed in future in Qt Quick 2.2, very fast and very easy. Then there is user settings, that is a set of file, ini file and XML file. The project, in the idea of the IDA application, the project describing the entire behavior of the component. You load the project and the application set up the behavior and the call and so on based on this component. And then live data. Live data is the first part that we are presenting here, because it was the most complex. Many graphics, different graph elements to be plotted faster at reaching a frequency of at least 200, 300 Hertz. This means one interrogation to hardware, one tick to the hardware every 25, 30 milliseconds. Give us the option to monitor components, and then should be extracted, because it is also one of the first 3 bad blocks that are developed in web components. The reason that I was saying before, I have not moved the port into Qt 5.6 because until this is not completed, the web components are not removed, so Qt 5.6 adopted the new web engine, faster but heavy to remaster again. It was a part to disappear, destined to disappear, so it was not the world to change this. Another idea that was not totally reliable. No? These are the steps we continuously met problems and issues. The problem to make this this kind of intervention, this kind of revision, to make it reusable, strongly reusable, is to create a sort of model templates and reapply the base elements to the other, all the other parts of the interface and the view controller, not only the interface itself, because there are also calculations and so on. This was not possible because data flow is too fragmented. Taking account, just to have an idea, you should consider that one of the wrong choices of this initial architecture was the use of the signals. Python uses one signal class. Instead, the guys that have developed the application discovered that PyQt signal is fantastic because create a Qt signal. The problem is that this is used for speak from Python to Qt. I send the signal, so Qt intercepts it, and I can have separate two parts working. Instead, in the logic of using everything of the Qt elements as libraries, they use every variable, instead moving a pointer to a class, they create a signal. So it's possible to use the signal somewhere else in Python. The result was that there was about 170 signals managed in the application, never used by the Qt framework, but only used in the Python environment, creating an extremely complex path of data exchanges where almost 60–70% was redundant, because without documentation, you can imagine. So, keeping in mind what are the goals, another solution was found. That is the solution that definitely it was used. Sorry. Okay. I see different things from there. Okay. The creation of a view controller element that is Qt driven, for now without plugins, but can accept because it's a separate folder, physically separate in the application. Then, the only solution as, for example, one change involves not the class that manages that signal or that data, but involves 3, 4, 5 classes that exchange data almost randomly. I have created a switch in Python, a global switch, that when you set the switch, some classes that are normally used in the old version will be switched to the view controller component, where I have totally cleaned, changed the Python classes, and are exactly as the interface should work. Qt, framework elements, view controller, so all the interaction is under control of the graphic part of the user interface, the user can manage things and so on, exchange data with Python components, and these classes are hybrids that are only with the need parts while the other are physically deleted. And there is, inside the module switcher, there is an intermediate class that manages just the signals between the Qt world and the Python world. So the application can go ahead for all the other components by itself in its original way, while the single parts that are under replacement are managed by the new area. The goal is to reach this final situation where all the elements that may be part of a user interface, also a flag, also a dialogue, will be developed completely working under Qt, and in this area, this view controller folder that is pure Qt, while Python remain maybe almost scrap, but anyway remain a model, operational part of the software. And we finally, in that moment, we are able to remove the problem, the really original issue, that is Python launching Qt, that starting discussing to Python, to asking Python to send back data. That makes this trouble in the application. So, QtQML components, the connection class, the framework to the Python, and then the Python module architecture that is, as a matter of fact, how the software now is working in the original phase. How to develop this part? Because keeping hands on these classes, discover what should be removed, what can be removed without impacting in issues and so on, is almost complex. So, first, it was created with a complex randomizer class in Python, a simulator that works just like how data are sent in the moment that should communicate between the Python and the Qt components. In this simulator, totally compatible with the kind of data that we really will have to use when the application will work, it has been created a test bench to calibrate and study these graphics modules. This is the idea, and as you can imagine, in Qt this is almost easy, creating every part, focusing in every part the component, and then the graphic is totally parametric. It is managed by a JSON configuration file. So, as well, when the Python program starts and loading from the project discover what is the hardware in that moment working, automatically it recognizes the hardware ID. Based on the hardware ID, loads the JSON file in the Python, the Qt part, load the JSON file and adapt the graphics with the limits, the behavior, the title, the x-axis, the labels, and so on, depending on the hardware. So, just to give you an idea of the complexity, just the plot elements are a set of almost 30, 50 different variables that are managed every call. Every time that a tick is sent to, a poll is sent to the hardware layer, the chip sends back about 8 KB of data that are all the variables that it has available. So, the Qt part should identify what are the variables between these 50 ones, what are the variables that should be plotted really, limit this, and optimize the plotting and the behavior to these variables. One graph, then the same model in the simulation approach was developed. Simple, a grid system with a control bar for user to manage zooming, activating, because you have 50 different graphs, you have a pool of 6 visualizations in the same time. The original version in the web view was showing, no idea why, 40 different graphs in the same time. Absolutely impossible to see, because you can imagine what you can, obviously, absolutely stopped, very heavy, with 40 different web instances under PyQt managed directly by Python. This is the ideal design of the new interface, and then clearly focusing the parameters that are the control of the user, partially manually, partially automatic. Is obvious, almost obvious, grid lines, one density, what do you want, how many points, and so on. The interface, at this point, enters another part. This is an open source framework that will be also released on GitHub in this part of this of the attachment of this conference. That is Qt Complex. I developed this a few years ago for Nokia, because it is a framework that optimizes the creation of toolbars, buttons, based on themes, And it's interesting, it works on any platform, but in terms of Nokia works from Symbian, Linux, embedded Linux, up to the desktop versions. And then it makes easy for me, very faster to development life cycle of the graphic elements, because most of the parts that are conventional standard Qt Quick 2.2 components are already pre-built with the parameters. The version that will be released is a version specifically adapted, because obviously this framework was working with its own plugins in C++ that here are not possible to be used, can't be used, so are replaced with a version that is updated to Qt 5.5.1, support Qt Quick 2.2, and is JavaScript and QML only, with anyway keeping a good results in terms of speed. So, where we are arriving? To create the things that should be avoided in any literature, a parallel architecture. So, an architecture in version that is in progress by one side, moving everything on Qt, and also simplifying, removing classes, removing objects, removing parts. Python becomes more under control. And the original, the traditional version ported to Qt5, by Qt5, where the core of the application remain until we don't remove and move and push on the other side. So this means two timelines, and then there is a slide with some sample data almost clear, but taking account that we have, it was possible to create a 10 factor between the interface ability to plot data. So the simulator is able to work with 6 graphs, plotting every graph as 2 lines, because audio is stereo, so left and right parallel data that are sent. So 12 plotting data in the meantime, one plot every 25 milliseconds, only in JavaScript support. So I imagine what the result we will get with the better plugins in C++. By the other side, Python is able to send back data every now 125, 150 milliseconds, depends on the kind of connection. Now, this is the starting point after porting, after acquiring the knowledge, after all. So you see that there is all Python, an application entry point that is run, just run is the name. Then immediately go to a creation of the Windows user interface. This interface, design widgets, design dialog, design contains, everything hidden or shown. Then create 3 web view. Every web view is custom, so should be removed also because we need to make modular and adaptable to any kind of device. Else, now for device, new chip, new development of the new, another web view specific for the chip. Then there are components that are runtime and device interface that speak continuously, poll with the hardware, and send data throughout this 170 PyQt signals not used by Qt, because Qt is not used but only as a library to design things under the Python control. So, the live data inversion, the architecture inversion, should start from one module, first the most complex and the most issued and slow plotting data, and then as this is done, every parts can be moved and reused the parts that we have already developed. But because Qt Complex is a standard framework that now it is used by tons of users, almost stable by years, and is well known by me as I have created and documented. Also because the architecture in the QML, Qt is done strongly modular, and also because we can manage inside of this sort of protected container that is the view controller in the new architecture, manage also the Python classes that has strong issues and remove the parts that we know. So the idea, in my opinion, is the only possible idea in a situation so dramatic, is just starting from the first web view, removing the second, removing the third, and then step by step moving everything to the other side to have the final Qt architecture, really the view controller model that act like a caller to the Python. Instead, Python calls the architecture that should manage itself. This is the problem. These are the advantages. Okay, based on the tests, physical tests done with profiler in Python and with the simulator in the Qt design, we have a range between 20. We have a change of 125 milliseconds with the ability to manage 25 milliseconds. Taking account that anyway, for now, we manage a call every 25 milliseconds, but sure, data are replicated because the hardware layer controlled by Python is not yet totally clean and is not yet totally fast as we need, so not always able to send the data, and the system, the reason that should work totally asynchronously. Qt go and simply ask information, if available, change data, else replot the same point, so we can have a constant tick, a series constant tick. Python manage hardware as its own frequency. In the optimization process, we expect we can reach 15, 16 milliseconds every tick in the polling, and then when the entire project is moving, we can reach the final. These timelines are a bit, I kept everything as low as possible, no? To be sure that then the application will work in a real environment. So, timing of 25 milliseconds instead of 125 and so on are all based on a virtual machine that is already a bit slower, with configured Windows 10, a single core, and only 4,000 KB. So it's a very poor machine, and anyway is far to be the machines that usually are managed by are owned by the users to manage live data. So this is where we should be. Created a new architecture design that includes all the user interface, and when the Python includes only the parts related to the model, as we consider, no? Speaking with the hardware and so on, we can also finally remove that perversion of the Python launching Qt, but maybe Qt that start the Python model, and the initial idea to have the Qt view controller starts the interface, load the project, design the project based on the hardware that this project describes, set up everything, then use Python just because it's useful for us. No? It's already done, it's already working for now, that's okay. Use Python as a Python plugin from Qt, as well as the fast design object for the other part of the interface that are C++ plugin. This is the kind of job that is done. I plan to release, according with the parts that can't be obviously released because are property of NXP, anyway, as open source, the core scriptlets that I think that are useful if someone is interested to show how this approach is done. For example, the graphic engine that has been optimized, spending a lot of time due to the limitations, is a pure QML and JavaScript engine, self-adapting, uses the framework, and is interesting to release itself as an independent object, open source. No? In this case, it's used by NXP, but they almost open. I appreciate it also very much, because working with this crew was interesting, because when I say, okay, this may be useful for all, the question is, this impact with the information of the company? No, it's a generic element. So programming and developing the architecture with a minimal of logic, many paths can be in effect distributed, and this is an advantage for all. Huh? Now, I want to show you just a couple of minutes of a video that is a screencast that I have produced with actual results to give an idea of what we have spoken, and it's okay. Okay, I can start. Now the two interfaces start under Python control, but are independent, so are totally different processes. This is the original interface. Everything disappear, and the other, okay, hardware is recognized. System sets the hardware, organize, optimize parameters. Then the parts that should be initially shown here are shown there. Note that graphics self-adapt and changes as the hardware is set. Okay, it recognizes the kind of parameters that should be shown, what are the limits of the graphics, and so on, based, and start plotting. Horizontal lines depends, because the fast plotting in the user interface asks more frequently to Python data that Python is not yet available, so data are replicated anyway with a reliable result of the return. Obviously, now seeing these graphs that I think is self-adapting, these features like adaptability, many elements of restyling should be already done, but it is just the last point reached not to show now the very few, the very first preview of this project. The adaptability makes this that also immediately resize. These are features that are all under control of Qt. This is the initial impacting interface. As the elements are removed, the interface becomes more complex with over menus, over components, and this becomes one part of the view element. Now we see 6 graphs because I use 6 graphs. Originally, if you have 30 variables or 25 variables, they was showing 25 different web views, not only, but plotting the graphs that you wasn't seeing. So it was the very, very heavy, very dispersing and very time-consuming mechanism. Okay, this is the scenario and the case that I am. This is the first phase of the challenge I have survived now. Okay.
Thank you, Enrico. Are there questions from the audience on the NXP use case? Please raise your hands and I'll give you a mic. And otherwise, I have one question. You're moving a lot of functionality from Python to C++.
Yes.
And traditionally, we'd say Python is a rapid development language and C++ takes a lot more effort. Do you notice that in porting the application in the way that you're doing?
Python is, I think that the best definition of Python usage is in the QtDoc. No, this is a fast prototyping software, no? You can really develop very fast, but it's a sort of mirage, no? Because you have Python do everything, also especially in embedded system, BeagleBone on Raspberry, any kind, there is a library of Python. What is? It is a strong C++ component that someone that is able to program has developed, and then you use Python because you have a wrapper, like just PyQt5. This is the big misunderstanding. No? Python is nice because it's useful to interface strong languages. But if you think to develop in Python strong applications in Python, this is essentially an error, no? A formal error, because you make, just like developing it in an interpreted BASIC. Having an infinite time, no, a very good big company group, instead I was alone developing this. Okay, guys, these are the functions. Develop the C components and make the wrappers. So extend the PyQt5 library, but has not so much sense because it's better that we use the standard, else we should imply a maintenance of non-standardized components that become heavy and very expensive in the future along the time of the application. So it is better for now to adopt the compromise, okay, Qt, QML with Qt Quick 2.2 is anyway very fast. And it's very flexible because this is a totally, for me it was every week a totally unexpected behavior, unexpected thing, a new issue, things impossible to discover why, reverse engine continuously. So Python, okay, remain until we can't remove, or we can use just like the rapid prototyping or rapid development. But Python calls anyway faster. Why? Because there is a DLL. The DLL is the simulation of the Android Linux component, and is the DLL that works low level, developed in C++, that asks to the hardware and send back information. It's not Python. It is a sort of false vision that has I see many users have, no? They say, also especially Raspberry Pi or embedded application users, they love Python because with Python you can do everything. You do nothing, because the producers release Python libraries that are anyway wrappers of C++ libraries. This is good for teaching, is good for newbies, is great approaching program, because if you have not so used by Qt, okay, develop, make a test with Python. Make a fast source, but not an architecture complex that is treating so many data in a cache. In Python, they have developed the ini file parsing. It needs 10 seconds to open a file. It has no sense. But it's not a problem of Python. It's the wrong usage of the language. Because it's using a thing with another function. No? It's like use a crystal glass as a hammer. No? And then you can't complain that it's broken. No?
Thank you.
Yeah.
Other questions? If there are no other questions, I'd like to thank Enrico for his talk. And
thank you. I hope it was interesting.